Hello everyone, Mr. Minix, my name, math is my game, and on today, we're looking at factoring with my advanced group here. Yesterday we introduced it. There's another video called Intro to Factoring where we talked about factors of numbers. And I believe we looked at some basic factoring like when A is 1. The Common Core Content Standard, you don't need to know that. It's kind of weird that they use ASS. When they talk about the standard, it says algebra, seeing structure and expressions. You'll be able to see the structure to identify ways to rewrite it. So of that whole bit of the title slide, really the only thing I'd write down is 4.4, factoring quadratic expressions. And where they say factoring is a rewriting an expression into the product of its factors, that's good. I really like that. That's a good thing. This is good. Factoring is rewriting an expression as the product of its factors. That's all you're doing. Something that was brought to my attention while teaching geometry shocked me. I'm not easily amused. I'm not easily amazed. But when I was teaching geometry, hello. She went to the office and was there, but sorry for the delay on the video. So what surprised me when I taught geometry is there was something that went x squared minus 5x plus 4. And you had to factor it. And so you do this. And the reason, do you remember in geometry when you did proofs and you had to give a reason for your step? You know what the reason is why factoring works? Does anybody know? Maybe you didn't like geometry. I didn't either. What's the reason that you can factor? There's got to be some property that lets you do it. Yeah. It's a distributive property. It's the distributive property. And I know you're thinking to yourself, self, no, it's not. Well, yeah, it actually is. Watch. What happens if we use the distributive property and distribute x to both of these? We get x squared minus 4x, and then we get minus x plus 4. So that's x squared minus 5x plus 4, which is what we started with. So factoring is really the distributive property backwards, or the undistributive property. It's kind of weird. Everybody's good at the distributive property, so in theory, everybody should be really good at factoring. I don't know why factoring's so much harder, but it is. All right. So they run through this example. They talk about being able to FOIL so you could check your work. That's cool. We all know that. All right, let's just get right into example 1. I love this. Most of the time, this is what we're going to be doing, just factoring a trinomial into the product of two binomials. So number A, we notice everything's positive. So we're going to set up our two binomials. If everything's positive, what do we know about the signs? They're positive. And what number are we looking at when we factor? We're looking at either the 9 or the 20, or both. We're looking at both, but which one gives us what our factors can be? The 20. That 20 tells us what our factors can be. Which one tells us what they have to be? The 9. So we're looking for 20's factors, either 1 and 20 or 2 and 10, that add up to 9, and neither of those do, so it doesn't factor. DNF. 5 and 4? How'd you know that 20 is divisible by 4 or 5? Oh, so I shouldn't have just stopped here. I should have found a complete list of factors before I jumped to that conclusion. Okay, so 4 and 5. So it does factor. Okay. All right. Glad somebody's keeping me honest today. A lot of people want to jump right to the conclusion that it does not factor. Don't be so quick to jump to that conclusion. Until you've checked the entire list of factors, don't jump to that conclusion. Okay. Any questions before we move on to number B? I know B is not a number. So number B. So we're looking at 72. 72's factors that add up to 14 or subtract to 14. It's not 2 and 36, not 1 and 72. It's not going to be 3 and 24. Not going to be 4 and, maybe it is going to be 4 and 14. Oh, because it's a 14 in the middle. That's not 4 and 14, 4 and 18, my bad. 4 and 18, that's it. X and a 4, X and an 18, what are our signs going to look like? Plus on the 18 and a minus on the 4? Cool. So these should be like a walk in the park. These should be like you got your strut on. Uh-huh. That's right. I'm good. I can factor. I know how to find factors. When A's 1, it's easy. Number C, you might want to make a mental note of this. I don't know why, but college algebra textbooks love to do these to you. And my best bit of advice, and I'm going to urge this, Mr. Engelhardt will urge you to do this, any math teacher that's worth their own, that knows what's good for them, always on one like this, factor out the negative first. Now, some people are going to factor it without factoring out the negative. You can, and it works. But I'm telling you, these are a whole lot easier if you factor out the negative first. Factor out the negative first. What I mean by that is we're going to write a negative in front of the whole thing. It's going to be x squared. Every term's sign's going to change. So then it's going to be what? Minus 13x and then plus 12. So this negative that's hanging out front, it's just going to get copied down here again. And it's going to be a part of our answer, and that's okay. That's okay to have it as part of the answer. So now it's pretty easy, right? Forget about the negative out front. Just pretend like it's not even there. La, 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 la. I don't even see you, negative. But I could factor this. What are we going to have? X and an X. 12 and a 1 and the signs. Negative and a negative. There it is. And the negative sits out front. The negative does have to sit out front as part of your answer. You can't just discard it when you're factoring. I'll say that again. When you're factoring, you can't just disregard that negative and say it goes away. Which is kind of weird, kind of confusing, because when we start to solve equations, we can actually disregard it. If we were solving an equation, we could disregard it. But when we're factoring, that negative has to be evidence that multiplying this expression back out would lead us to what we started with. Does that make sense? Good. We going too fast through this, or are we all right so far? All right so far? Okay. All right. Problem 2, they're talking about GCFs, greatest common factors. We kind of looked at some of these on yesterday. My suggestion to finding a GCF is to break things down into their prime factors. So if I look at 6, I could rewrite 6 in terms of its prime factors. That's 2 times 3, and n squared is n and n. And if I look at 9n, that's going to break down into 3 times 3 times n. So they're actually asking us to factor it. Sometimes you might be asked, what is the GCF? So if they ask that question, what is the GCF on this one? The GCF is all the stuff that both of those terms have in common. And I'll highlight what I mean when I say both of those terms. This is a term. This is a term. Terms are separated by addition. So what's the most stuff that those terms have in common? 3 and a n. So our GCF here then is 3n. If they ask you what's the GCF, that's the answer. But they say factor this. They're asking what's the expression in factored form. So they're essentially saying factor this. A lot of times in math we don't understand directions. So I'm just going to rewrite that. That's what they're really saying. They're saying factor this. So again, we have to have evidence. Whatever our answer is should multiply back out to be whatever we have. So our answer is going to have 3n in it. Remember, we're doing the distributive property backwards. We're undistributing. I like doing this method because watch what happens. I'm going to wipe out my 3n. I'm going to wipe out my 3n, and whatever's left just gets dropped into the parentheses, right? So what's left? 2n plus 3. I don't know how you feel about that, but I think that's pretty cool. I think that's pretty neat. Bless you. So one of my movies that I go to if I ever need a good laugh because of something being so annoying is Dude, Where's My Car? I like annoying stuff. I don't know why, but I like stuff that just kind of gets under most people's skin. My wife calls it my OCD kicking in. I'm like one click away from being OCD. I've actually gone to psychiatrists and been tested for OCD, and I'm really close to being OCD. At night, when I used to go to bed, I'd have to touch the faucet with the right hand, right hand. And then I'd take 3 sips of water, and I'd do it again. And if anybody talked to me before I went to bed, I had to do the whole thing all over again. I know it seems weird. Anyway, there's this movie called Dude, Where's My Car? And the scene is this. They drive up to the drive-thru to get some food. They say, yeah, I'll have some General Tso's chicken. And then? Yeah, and then some crispy noodles. And then that's it. Oh, wait a minute. Yeah, the wonton soup. The scene goes on for 4 minutes, and they keep saying, and then. There's a reason I say that. Number 5 has an and then. Don't ever forget about the and then. Don't ever forget about the and then. There's always something else you could do. This one, we're going to factor out a 4 first. Factor the 4 out first. So when we factor a 4 out, it's going to be 4 times x squared plus 5x minus 14, right? If you're not sure how to divide something by 4, that 56, cut it in half. Half of 56 is 28, half of 28 is 14, right? But don't forget about the and then. The and then is, yeah, we factored the 4 out, but this part that's remaining factors again, doesn't it? Don't forget about the and then. So we've got 4, parenthesis, 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 parenthesis. I wonder if 14 has any factors that add up to 5 or subtract to be 5. 7 and 2. X and a 2, x and a 7. We want it to be a plus 5, so plus on the 7, minus on the 2, and that's it. Any questions, comments, concerns, short or long debates about anything there? Yeah, question. Does it matter which number goes in which part? So if you wanted to write your answer as 4 times x plus 7 times x minus 2, that's fine because of the commutative property of multiplication. However, if you wrote your answer as 4 times x plus 2 times x minus 7, in that case your signs, wouldn't jive. Okay, so that's a good question. Yeah, it doesn't really matter what order you put these 2 binomials in as long as your signs are okay. Excellent question. Any other questions before we move on? Do we need to do any of the got it's, or do we got it? Anybody want to look at any of the got it's, or are we good? Good? Okay. Maybe you could try those on your own. This will be up a PDF up online. Okay. Oh man, here we go. I wish they had a whole bunch of these. Factoring when the A value is not 1, and when you can't factor out a GCF first. So there's this technique. There's actually 2 that are real similar. I'm going to show you the magic X. I don't know why they call it the magic X. But the magic X it starts off similar to one way I showed you yesterday. Just about any time you do any of these, you're going to take this first term and this last term, and you're going to have to multiply them. So let's think about this. What's 2 times 12? 2 times 12 is 24, right? And that is a positive 24. Okay? And then if we look at the middle term's coefficient is plus 11, right? Plus 11. So when you factor, regardless of whether A is 1 or not, you're going to have to be able to factor to factor. What I mean by that is you're going to have to be able to find factors of a number to factor. We're going to have to break 24 down into its factors, 1 and 24, 2 and 12, 3 and 8, 4 and 6. And again, we're looking for a pair, but this time that pair's got to add up to, or subtract to be how much? 11. So I think we see our winning combination, 3 and 8, right? So we're going to write a plus 3 here, a plus 8 here. And here's where this magic X gets a little weird. Here's where the magic X gets a little weird. There's this new catchphrase that was popular about 3 years ago. It's called unpacking. Anybody ever hear that catchphrase? Politicians like to use it. Anyway, what we're going to have to do now is we're going to have to go back to the beginning, back to this leading coefficient, and we're going to have to put that in the denominator. We're going to have to put that in the denominator of those numbers in the wings. Everybody with me so far? And then if there's a fraction that can simplify, like there is on the right wing, see how this 8 over 2 can simplify? Let's go ahead and simplify that. That's going to be, what, 4 over 1? So that's going to be 4 over 1. Okay? So now what we're going to be doing is we're going to be using those things. We're going to use this, we're going to use this, and that's part of our answer. That's part of our answer. The denominator is going to be the coefficient. You might want to make a note of that. The denominator is going to be the coefficient. The denominator is the coefficient. So our answer then, our answer is going to have the denominator of, in this case, if I look at this one here, 2 of 2x. And the signs are going to stay the same, so it's 2x. And then the other numbers, the numerator is the other number, so 2x plus 3. And then I look over here, the denominator is the coefficient, so 1 or 1x. And I go with x plus 4. And magically we've factored that. What do you think? The question is, where's the 2x come from? The 2x, this 2x plus 3 comes from this. The denominator ends up being the coefficient. Question. Where did the 24 come from? The 24 came from multiplying the first and the last terms, the a and the c value. Okay? And anytime you factor one in this form, a trinomial where a is not 1, you're going to have to multiply a by c. That's how you start all of them, regardless of what technique you use. Okay? How do we feel about that? You like it? I really hope there's a lot more examples of these with a not equal to 1, because they're awesome. Number B, do we want to see that factoring by grouping in action again? Or do we want to maybe guess and check? Guess and check? Grouping? Factor by grouping. If you missed it yesterday, check out the video on it. It goes RA plus RB plus SA plus SB. You got to watch out. You don't want to say some of that stuff in Youngstown. That's R times A plus B plus S times A plus B. So it's R plus S and A plus B. So the trick to this factoring by grouping is you got to have 4 terms, and we don't. If you're not sure what the A and the C I'm talking about are, we got to multiply this 4 by this 3 to start this off. What is 4 times 3? 12. 4 times 3 is 12. 12's factors are 1 and 12, 2 and 6, 3 and 4. And I want to somehow, some way rewrite this minus 4x using a pair of 12's factors. It's not going to be that pair. It's going to be that pair, right? So what I'm going to do is I'm going to rewrite this. It's going to be 4x squared. It's going to be a minus 3 on the end. What's it going to be in the middle? It could be minus 6x plus 2x, and this is a cool thing. It doesn't matter what order you write this in. The factoring by grouping will work either way. It doesn't matter what order you write this in. Factoring by grouping will work either way. Do we want to go with the 2x and the 6x or the 6x and the 2x? 6x and 2x? Okay, either way it's going to work. Now, if we go with the 6x, that's got to be what, minus or plus? Minus, and then the 2x has got to be a plus. So the way this factoring by grouping works is you pair the front two together and you factor out their GCF. So what's the GCF out of those front two? 2x. So it's going to be 2x times 2x minus 3, right? Here's what I love about factoring by grouping. If you don't quite understand it, what you should know about factoring by grouping is the second binomial is going to be the exact same as the first binomial if factoring by grouping works. So this is kind of unusual. What do I have to factor out of 2x minus 3 to get 2x minus 3? A 1. I'm hearing nothing, but technically when you do that, it's a 1. It's a positive 1. So then my answer would be what? 2x plus 1. So what happens is this coefficient and this coefficient make up one binomial when just placed side by side. And the other binomial is that one that shows up twice. A lot of people mistakenly think they need to put an exponent of 2 here. That's a mistake. You don't. Because if you did that, you'd end up with something to the third degree. And we only have a quadratic. Okay? So this factoring by grouping technique, how do you feel about it? You like it? Don't like it? Question. So the question is, how come we didn't worry about the negative in this case? With this case, I could have considered the negative in there. I could have. Sometimes you do and sometimes you don't. That's a really good question. I guess with the factoring by grouping, it's not so relevant that you worry about whether that AC product is negative or not, if that makes sense. Excellent question. Really good observation. So I wonder if they've got another example for us. They don't. Give me a split second to dream one up, because I want to try a really nasty one and see how bad they could get if we had to try and guess and check maybe. Okay, this is a good one. Example, factor 32x squared minus 4x minus 15. Oh man. The problem with the factoring by grouping technique on this, or the magic X technique on this, is we're going to be dealing with a wicked huge number to have to break down into its factors, aren't we? Oh my goodness. 32 times 15. It's going to be 300, another 20, another 150, and another 10, right? So it's going to be 450, 60, 70, 480. So I want 480's factors. All right? You guys never saw multiplying that way? Okay. Well, anyway. So I want 480's factors. 480's factors. 1 and 480. Boy, this is going to take forever. Oh, man. Maybe it doesn't factor. Maybe it does. 2 and 240. Does 3 go into 480? Yeah, 4 plus 8 is 12. 12 is divisible. It's 3 and 160. Going to be 4 and 120. Going to be 5 and something. It's going to be 9. That's a 96. 5 and 96. 6 and 80. 7. I wonder if 7 goes into 480. 7 times 6 is 42. Nope, 7's not going to work. 8's going to work 60 times. Does 9 go into it? I don't think 9 does. 4 plus 8 is 12. 12 is not divisible by 9. 10's going to go into it 48 times. I don't think 11 works. 6 worked an even number of times, so 12 is going to work 40 times. 13 I don't think does. 14 doesn't because 7 didn't. 15 into 480. That's 3. That's 45. That's 3. That's 32. So 15 and 32. 16 and 30. 16 and 30. 17 I don't think does. 18 doesn't because 9 didn't. 19 doesn't. 20 will go 24 times. 21 I don't think does. 22 is not going to. 23, and we're back to, that's it. That's all of them. That was a long time to find those factors. So what technique do we want to use? Do we want to use the magic X? Or do we want to use guess and check? Or do we want to use factor by grouping? Or do we want, which one? Magic X? Okay. So the magic X says I got a product of negative 480. And I want factors that add up to negative 4x. So I'm going to have to go with what and what? 20 and 24, right? 20 and 24. Now my signs are going to be what? Plus on the 20 and minus on the 24, right? So on the magic X, you are incorporating signs. And what goes in the denominator? The leading coefficient, so 32. And I should be reducing these fractions down if I can. 20 and 32 are both divisible by at most 4, right? So that's going to make this 5 over 8. And 24 and 32 are both divisible by 8, right? So that's going to make that 3 over 4. So my answer is going to be comprised of 2 binomials. Remember, the denominator is the coefficient. So it's going to be 8x what? Plus 5 and 4x minus 3. You guys like that magic X method? Or do you like the factor by grouping instead? Or do you like guessing and checking instead? Okay. All right, so now they're talking about specials. I mentioned these the other day ago. Specials. The specials, there was one that's, if you remember right, I used these weird triangles like this. I kind of like these triangles. Flip it from up to down. You probably have this in your notes somewhere. I want to make them different colors. Make the one blue and the other one red, I guess. So a perfect square trinomial, what makes it so special is its first term is a perfect square. And its last term is a perfect square. And its middle term is really special. And we'll talk a lot more about this in a later section of the chapter. What ends up happening in the middle, though, is if you take the square root of the first term and the square root of the last term, multiply those and double it, that's what the middle term has to be. Now, it's always going to be plus the term at the end. And in the middle, sometimes it's a plus here. Sometimes it's a minus here. Doesn't really matter. But when you have a perfect square trinomial, it's called a trinomial because there's three terms. Perfect square because you have perfect squares on the front end and the back end. They're real easy to factor. You should be able to factor these in about 1 second flat. What happens is a perfect square trinomial factors into a binomial squared. And I know people don't like my acronyms, my abbreviations. But what I think is, well, I better not say. Anyway, it's going to factor into an A here and a B here. And if it was a plus, it's going to be plus. If it was a minus, it's going to be a minus, and that's it. A lot of people struggle with this. They're like, dude, that doesn't work. Yeah, it does. You just forget the FOIL method. You just forget when you multiply things out what ends up happening. People really struggle with the perfect square trinomials. They don't like them. They don't believe it. They don't trust it. This blue chair that I've got, I sit down in it quite a bit. I trust the chair. I have faith that it's going to hold me up, that I'm not going to fall on the ground when I sit on it. Have faith, trust this pattern for a perfect square trinomial that's going to work. Trust it. The other one is a difference of two squares. A difference of two squares, it's when you have some perfect square. This is why I wanted you to memorize your perfect squares, by the way. That reminds me, I was supposed to give a quiz on that, wasn't I, this week? Maybe that'll have to be on third. A squared minus B squared. A squared minus B squared, like that. So you'll notice there's a perfect square up front, there's a perfect square in the back. And there's just a subtraction sign between the two, hence the name difference of two squares. When you factor those, if you didn't notice this from the foiling championship, I put a bunch of these in there. What ends up happening is you end up with the exact same looking binomials, an A and a B and an A and a B. And one of them's a plus and one of them's a minus. And that plus minus nature is how the middle term drops out. That's what makes that middle term go away. When you have to factor these should be easy. You should look at these and say, yes, I got these. These, and when A is 1, I can factor these all day. All day. Easy money. I got these. So here we go. I love this one. Have I mentioned that there's more than one way to the Eastwood Mall? Have I mentioned that sometimes you leave the hot dog shop and you're scared because it's the west side of Warren and you turn the wrong way and you're driving and you're like, oh man. And you're driving and you're like, oh man. And you're driving and you're like, oh, it's Eastwood Mall. And you end up there by accident. What I'm getting at here is there's more than one way to do this one. And if you do it the one way, you're going to have a little bit more work later on. Anybody notice anything about 4, 24, and 36? They're all divisible by 4. If you didn't notice that they're all divisible by 4, and if you didn't factor out a 4 first, it's okay. It's okay if you didn't. It's okay if you didn't. So 4 is a perfect square, right? 4. So what ends up happening, since this is a perfect square trinomial, the answer is going to be a binomial squared. It's going to be a binomial squared. The first term, I just got to take the square root of this first term. What's the square root of 4x squared? 2x, right? Okay. And then the last term, I just look at the last term and I take the square root of the last term. What's the square root of 36? 6. Square root of 36 is 6. And then because it's a minus in the middle, it's going to be a minus right here. And you might think that this is your answer. You might think that's your answer. However, that's not the best answer you could give. There's more work that you have to do. Technically, this is 2x minus 6 and 2x minus 6. And out of each one of these, you should be factoring a 2 out, shouldn't you? The product of this 2 and this 2 is going to make how much? 4. Right? When you factor, you want to have any GCFs at all factored out. So maybe it would have been better off had we factored that GCF out right from the get-go, huh? So you might want to make a mental note and a physical note to yourself in your notebook somewhere, highlight it, put it in all caps, factor out any GCFs first. If you can factor out a GCF first, do it. It's going to make things way easier later. Factor out any GCFs first. Factor out any GCFs first. Factor out the GCF first. Anytime you can. Okay. It's just going to make life easier for you later on. Yeah, question? Question, if you left it here, would it be wrong? It would be. Anytime you have a perfect square trinomial, it has to be factored into the binomial squared. Okay, good question. Yep. Because remember, factoring is writing it out into the product of its factors. Okay, excellent question. Excellent question. How are we feeling? All right? Well, certainly they got more for us than this. Another perfect square trinomial. Nice. Good. So our answer is going to be this, right? A binomial squared. To get the first term, all you do is take the square root of the first term. So it's going to be 8x. To get the last term, you just take the square root of the last term. 1, and what's the sign? Minus. Now, I know somebody out there's thinking, but dude, those don't multiply out to be what it is. Really? Really? If you took 8x minus 1 times 8x minus 1, you're going to get 64x squared minus 8x minus 8 more x plus 1. It multiplies out. Trust it. Believe it. It works. Okay? All right. Moving right along then. Oh, here it is. I was wondering where it went. Problem 5, difference of 2 squares. Remember with these, your answer is going to be 2 binomials plus or minus the same stuff. To get your first term, you just take the square root of the first term. So it's going to be 5x. To get your last term, you just take the square root of the last term. So what's that going to be? 7 and 7. There it is. There it is. These should be a walk in the park. A piece of pie. The Godding, let's look at that. Binomial, 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 plus minus. So we just take the square root of the first term. So what are we going to have? Square root of 16x squared, 4x, and the square root of 81, 9 and 9. I think we're getting pretty close to the end. If I haven't mentioned this yet, make sure you have these numbers memorized. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Just about everybody has those first 10, right? Because you learned your times tables. But what about the next 10? Do you know 11 squared? 121. Do you know 12 squared? 144. 13 and 14 should be really easy to memorize. 13's 1 something. And 14's 1 something. And the numbers just flip-flop. 15, I always remember the time I took my dog Xena on this road that goes to Paris or Rome Township down by West Branch. The road goes up and down and up and down. It's real hilly. Anybody know the road? 225. 16, if you think about computers and computer memory, and computer RAM, and computer hard drive sizes, You might think of it. 256. 17's a tough one. Most of you probably don't even know when the Mustangs first came out. I don't. 289's the first engine, the first V8 engine they put in them. So 17 squared is 289, 18's 324, 19's the one that always gets me. I always screw up 19. It's 3-something-1. It's 361, and then of course 400. Okay. Some other notable ones to know maybe would be 900 and 1600 and 2500, right? So make sure you're familiar with those perfect squares. It's just going to make life easier on you when we have to factor things. Okay. So if you don't have these committed to memory yet, work on that. With that quiz on Thursday that you're going to have, that's going to be a tough one. I don't want to put too much on you, so maybe Tuesday of next week we'll have a quiz over these. Okay. So I believe that's it. Any questions about factoring? Comments about factoring? Do we want to try one more where A is 1, or are we okay? All right, that's all I got. It's been real. It's been fun. I want to give a shout out to the future Mr. Minnick for being such a great guy.